Hello, everyone. My name is Soumya Bhausar. I'm project manager on the hydrogen fuel cell electric bus demonstration and integration trial at QTRIC. And welcome to day one of the Canadian Smart Rail Technology Conference organized by QTRIC. Today, I'm joining you from Calgary. I'd like to acknowledge well, before proceeding with our panel, I'd like to acknowledge the traditional territories of the people of the Treaty 7 region in southern Alberta, which includes Blackfoot Confederacy members, Siksika, Piikani, and the Kainai First Nations, the Stoney Nakoda of Bearspaw, Chiniki and Wesley First Nations, the Dina of Tsuut'ina First Nations, and the Métis Nation Region 3, and all those that made Treaty 7 lands their home. We kick off day one on the theme of hydrail now, getting to zero with hydrogen propulsion and fueling systems in rail, what lessons we've learned so far. We have really interesting case studies to discuss here. We have panelists from some very interesting organizations in this space. But before we proceed, I'd like to thank our sponsors, Ballard Power Systems. We have Terry Howe joining us from Ballard today. Terry is Business Development Manager at Ballard, and I'd just like to welcome Terry on the stage here.
Thanks, Soumya. So on behalf of Ballard Power Systems, a leader in PEM fuel cells, we're very pleased that you could join this session on case studies of hydrogen in rail applications. I think there's a short video that we'll play now.
And so as we kickstart, I'd like to quickly introduce the panelists for today. So starting off, we have Terry Howe from Ballard Power Systems. As I said, Terry's Business Development Manager at Ballard. We also have Kyle Mulligan joining us from CP Rail, Kyle's Chief Engineer at CP Rail. We also got Andreas Hoff-Richter from DB Engineering and Consulting USA, Inc. Andreas is lead on sustainable mobility and zero emissions technologies at DB. And ultimately, we've got Ian Hodgkinson, who's Marketing Director of Transit Systems at Alstom Group. So I'd like to welcome you all. Thank you so much for joining us today. And we look forward to insights from you. So we'll kickstart the panel with a presentation from Terry. And Terry, I'll pass it on to you.
Thank you, Soumya. Yes, I'm a business development manager at Ballard Power Systems. I've pulled together a few slides that I can walk you through. I promised to keep this to 7 minutes. And so there will be time for questions at the end of all the presentations. One slide on Ballard. We've traditionally specialized in heavy-duty applications. So for Ballard, that's bus, truck, marine, rail, and stationary power. And we have over 3,000 heavy-duty vehicles on the road, a little more than 1,300 buses, 2,200 trucks, and 7 rail projects. And I'll go through more detail on the rail projects in this. Ballard itself, as a fuel cell company, is somewhat different than many others in that we specialize right down to the core of the technology. So we develop and manufacture our own MEA. We develop and manufacture our own bipolar plates. Of course, we manufacture fuel cell stacks, modules, and also now through acquisition of Arcola have gained full integration, vehicle integration capability. In this material, I'll go through 3 case studies of different types of rail projects that we participate in. So the first is a light commuter rail. This train is operating in China, in Foshan. In fact, we developed modules that are operating in 3 of these trams through CRRC. Each of these trams are powered by 2 standard 100 kilowatt Ballard fuel cell modules that then have been modified to meet the rail standards. The train has 6 onboard hydrogen cylinders that provides that train a range of more than 125 kilometers. And these trains have been on the tracks in service since December of 2019 with a little more than 250,000 kilometers operated. On a slightly different path, whereas the Foshan trains were taking our standard products. With Siemens, we worked with Siemens a multi-year development project where we developed a very specific module dedicated to the new Siemens Mareo regional train. These systems, each of which is 200 kilowatts, utilize Ballard's latest fuel cell technology and is capable of -25 free start, true free start, and incorporates all of the rail standards. This is the standard now. This is the standard offering for Siemens in their Mareo fuel cell powered trains. And the last project I want to share is a project we have where we're extremely pleased to be supplying 1.2 megawatts worth of fuel cells to Canadian Pacific for a line haul locomotive that will be running in the Calgary-Edmonton corridor. These modules also utilize our latest fuel cell technology, and we are looking forward to this train being operational next year. Now I have Kyle Mulligan speaking right after me, so I don't want to steal all of his thunder, so he'll go into much more detail on this project. Okay. Thank you so much.
Okay, thank you. Thank you very much, Terry. My name is Kyle Mulligan. I'm the Chief Engineer at Canadian Pacific. Before I jump into my presentation, I wanted to just share who we are at Canadian Pacific. So we are a coast-to-coast railway based primarily in Canada, and we operate in the United States. We have over 1,200 employees, 12,000. We operate 1,200 locomotives across 13,000 miles of track. So as I mentioned, my name's Kyle Mulligan. I'm the Chief Engineer. I lead a team of 20 railroaders here at CP, and we call them railroaders because not only do they have the academic credentials to form a solid technical staff, they're also qualified conductors, locomotive engineers, rail car and diesel mechanics, welders, locomotive and car inspectors, and engineering rules qualified. So what that allows them to do is really combine that field expertise that they get through regular deployments into our operation and bring that back with their technical skills to solve real railroad problems. So targeted initiatives as opposed to kind of big bang initiatives that aren't adding value. Through the railway technology team, we find ourselves really at the center of operations, mechanical, and engineering. And we report to the associated senior vice president of those departments. We use our IS department to implement our concept ideas and all the way to realization. And then we play a role in supporting our network service center, so customer support, and our sales and marketing team. In addition to what I'm going to talk about today, we do a lot in our team, starting with our wayside detector network. So a number of detectors that are literally located beside the tracks, looking at bearing, wheel, brakes, all kinds of different aspects of every freight car and locomotive passing at track speed. We also do train dynamics and incident investigations through a series of simulation technology where we use the inputs from our detectors to recreate events and solve rail problems, but also optimize train designs and configurations. That leads into our advanced analytics and strategic technologies, so data mining and machine learning. And then we're also, we have a 1,300 square foot lab where we can do metallurgical and laboratory analysis. So we can cut rails, cut wheels, we can look at them under the microscope and so on. And that allows us to validate a lot of our design assumptions. All of this to say is that our main goal is to drive improved car and track standards. And if that's not enough, we look at air brakes and welding as well. So we have a diversity in terms of what we do from a technical perspective. And we're really that strategic railway technology team that focuses on operational problems. In terms of our business mix at CP, we're primarily a bulk franchise, and we move those commodities across border, ranging from energy, chemicals, and plastics, all the way to grain, forestry products, and potash. And some of those commodities also come from the United States back into Canada. And then, of course, we run all the way down to Mexico as well. So we cover truly the North American rail spectrum. Over the past decade, we've had initiatives to become the most sustainably driven railway in North America, starting with our head office campus. This used to be a rail terminal located in Ogden, Alberta, and you can see that it's been refreshed and rejuvenated to create the ultimate head office. In addition to the campus located just behind that building is a 5 megawatt solar farm as well. So we're drawing power from solar energy to power our campus. And we're pushing that envelope further, and that's really what I'm going to talk about today around our zero emission locomotive technology in partnership with Ballard. So our CPH2 program. So first of all, starting off with why us? Well, we've aligned ourselves from a board perspective and, to align ourselves with the investment community around our ESG goals. So we want to truly not just call ourselves sustainably driven, we want to be sustainably driven. We have 1,200 diesel electric locomotives to leverage and a significant expertise in locomotive modernization. So we do not purchase net new locomotives really within the industry as much as one would think. We reutilize our existing platforms, we modernize their electronics, we rebuild the engines, and then we give them a new life. But and through that process, again, that allows us to get more life out of the platforms themselves. If we look at our biggest costs, it's around fuel and labor, and of course, fuel. We anticipate headwinds with carbon taxes on non-renewable fuels. And also, again, that's our biggest contributor to ESG. Now, one would ask, why did we not move to a Tier 4 diesel engine, diesel locomotive? Well, when we purchase a locomotive, they are typically 50-year assets. And so if we think about those kind of key numbers out there in the world, 2030, 2050, if we were to invest in Tier 4 locomotives today, we would quickly find ourselves post-2050 still burning diesel fuel. So this doesn't align with our ESG goals. And so what we're trying to do is leverage our modernization strategy and incorporate zero emissions technologies so that we can build a zero emission platform. So traditionally at Canadian Pacific, we have a history of going against the grain and moving the industry to places where it hasn't moved to or as quickly as we've wanted it to, from the steam era to the diesel electric era, and now more recently, to the zero emission locomotive era. So we're very proud at CP, and that's one of our values, and that's what we're trying to push in terms of the industry. So why locomotives and what makes them good platforms? Well, they're already hybrids. So they're electric traction motors that are powered by a diesel engine through an alternator. And so if you can remove that diesel engine and alternator and replace it with zero emission technologies, you already have a platform that can leverage that those electric inputs to provide traction. And so if you look at the image on the slide, I've highlighted the image below, just drawn an outline in green, and those are specifically the areas that we're targeting to replace. And what we're doing is replacing it with what you see above. And so where the diesel fuel tank was, we have a traction battery system. Where the cooling system and rad fans are, we have our H2 storage. And where our diesel engine and alternator were, that's where we place our fuel cells. And then we have a newer electrical locker. And we're truly building this in a way that it's modular, such that we can retrofit existing platforms. So where are we at? And Terry alluded to, we want to get a locomotive moving by next year. So here's sort of our roadmap. We started in Q4 of 2020 with an operational lab, thanks to support with Ballard, that had a hydrogen fuel supply into a fuel cell, which through a control system powered a full-size electric traction motor, which you can see here at Q1 2021. Then we moved into regenerative braking development and testing, and at the same time, our locomotive fabrication and assembly. And now we find ourselves here in Q4, where we're doing our final integration, control system, and factory testing. And in fact, actually today is going to be our first movement test of the locomotive. So by the end of this year, we'll have a moving prototype, and then we're going to deploy that locomotive prototype into one of our terminals in Calgary. And we're going to do switching testing, and eventually we're going to move this out onto what we call the road, so onto a subdivision, and continue to do testing throughout our network. So just to sort of highlight what we're doing in this program is we've essentially moved from nothing in Q4 of 2020 to a full moving prototype by Q4 of 2021. In our phase 2, we've been fortunate enough to receive government support from the government of Alberta, so one of our Canadian provinces, and that grant is through the Emissions Reduction Alberta program. What that's allowed us to do is found and establish a global center of excellence in hydrogen and freight rail systems right here in Calgary, Alberta. These funds are to leverage the conversion of 2 additional locomotives. One is going to be what we call a switcher locomotives, and the second one is going to be an AC traction locomotive. So that really covers the gamut of different locomotive types that we utilize at Canadian Pacific, and the majority of locomotive types that are leveraged throughout North America. In addition to that, that the funding will also be used to create 2 small-scale hydrogen facilities, generation facilities, one in Calgary, which will leverage our 5-megawatt solar farm to generate green hydrogen, and then a second one, which will be placed in Edmonton, Alberta, which will leverage conversion of natural gas into hydrogen through steam methane reforming. That's really to parallel what capabilities we have in Edmonton around our oil and gas sector, and eventually we will add on carbon capture to create blue hydrogen. So the current benefits and challenges to fuel cell technology. On the benefit side, the power output that can be created from these fuel cells and battery combinations are similar to what we produce from a diesel engine. Zero emissions hydrogen generation sources are possible, and we're planning to prove that out through it, but before the end of next year. It provides us with a retrofit capability to our locomotives, so we don't have to buy a net new locomotive. And the technology can also be weaved into our existing modernization schedule. So we're really pushing hard to have that happen before 2030. And again, it is a technology that provides potential for CP to meet our aggressive ESG goals. On the challenges side, range is still not what we would achieve through diesel power. However, after this first conversion, we can already see areas to optimize in terms of adding more onboard H2 storage. The battery capacity that we're using is already double what we ordered for the prototype. So our next year's order is going to give us twice the capacity. And so we fundamentally believe with these continued improvements and optimizations through what we're going to be doing over the next couple of years, we're going to be able to achieve in parallel with the capability of producing small-scale hydrogen production portable facilities, we'll be able to achieve an efficient operating plan. H2 infrastructure, again, thanks to our government support, we're going to be solving that. The cost of fuel cells versus locomotive modernization. So right now, a modernization would cost about 3 times less than using fuel cells. But again, there are plans and things in motions to optimize those costs. And getting federal government subsidies. We've had a lot of challenges on our side just to capture some federal funding, and we continue to pursue that. But we also believe that that's going to be critical in terms of enabling us to convert as fast as we want to move. With COVID-19, of course, supply chain issues are on the horizon, so we're quickly trying to capture supply as quickly as we can for those additional conversions. And ultimately, because we're using slightly different technology, we're going to have to ramp up in our shops so that our technicians are able to handle the inevitable maintenance that's on the horizon. So. But again, with our partners and our suppliers, we're working to create those types of certain types of links that will enable us to do a lot of the maintenance ourselves internally. So overall, that was just a quick overview of our CP hydrogen locomotive program. Thank you.
Thank you so much, Kyle. That was fantastic. And as a fellow Calgary resident, it just gets me more excited to see what's on the horizon. We will now move on to our next panelist, Andreas Hofrichter. Andreas is from DB Engineering. Welcome on stage, Andreas.
Hello, everyone, and thank you for giving us the opportunity to speak. It's great to be part of such an exciting panel and talk about this amazing technology. As everyone else, I start a little bit in who we are. We are Deutsche Bahn, that's German for German Railways. We are by revenue the largest rail company in the world and also the largest integrated transportation provider worldwide. Our main operations are focused in Europe, but we also operate internationally, for example, in the Middle East and also in Southeast Asia. We don't have actual rail operations in North America right now, but our logistics arm, DB Schenker, is an operator. And here in North America, we also do have consulting services through DB Engineering and Consulting. And that's where I'm based. I'm physically in the Sacramento area here in California, where our headquarters is, and also our zero emission team is based. I'm primarily going to talk about our consulting services rather than our rail operations. And you've already heard about some of the projects that we've been involved with, so I'm not going to go in a ton of detail on those as other speakers have here. So what we offer through our zero emission team here, which is the Sustainable Motive Power and Zero Emission Technologies team, are some ideas here, anything that has to do with feasibility studies, what technologies will work for what applications within the rail sector. We develop implementation and strategies for agencies and also railroads. We support pilot and projects and prototyping. We can also assist with infrastructure design and modifications and construction, and overall energy assessments, emission assessments, well-to-wheel, so not just the zero emission on the locomotive itself, but also through the entire energy supply chain, and for hydrogen that can make a very big difference depending on how we create the hydrogen. My colleague at CP just mentioned two options. But now I'll get a little bit into the history and how DB has been involved with this technology. And for the Canadian audience, you probably really enjoy that. The very first hydrogen-powered rail vehicle in the world actually did operate in Canada. In 2002, it was developed here in the US by a company called Vehicle Projects. At the time, the company still had a different name. You see a picture on the bottom left. And that was then shipped to Canada and operated in a mine. Shortly after that, the International Hydrail Conference series and initiative started, and that's still ongoing. It's an annual event where people and experts with interest from policymakers as well as industry and academia come together to talk about hydrail expertise. Then one of the really big milestones here was the BNSF Hydrail Switcher project. In 2009, the locomotive has been demonstrated. The red circles around these different pictures indicate where DB and team members of my team had involvement with, and we are involved with that since, so I'm going to focus on those. That BNSF locomotive, I personally did the emission assessment and the supply chain assessment for that particular project. Then I'm not going to go through all of these as I don't have enough time. One of the other commercially available vehicles very early and often not represented is TIG-M. That's a company based in the LA area. They actually started building and selling hydrogen-powered streetcars here in the historic look, but they also offer a more modern look since 2012. The light rail sector and actually the freight sector were the first ones to introduce and explore the technology, which also makes sense as the demand for hydrogen and power is typically lower and the operations tend to be physically constrained. So it's easier to do that to prove out the technology. Then moving over to the Alstom Island vehicle, I'm not going to talk a ton about that because you will have nice videos and much better presentation than what I can just say. First commercial passenger operation on a regional train basis, so relatively high power compared to the others, relatively large range compared to all of the others. Developed by Alstom, operating in Germany and operating partially on DB infrastructure. Below on the BCRE one, that was the first operating hydrogen locomotive, practical hydrogen locomotive in Europe. You can see it looks a little bit like a photocopy, and I can say that as this was one of my projects as part of the PhD, started in 2009. Loco was ready in 2012. And that led to all of the other initiatives that we're seeing in the UK right now. NCDOT was actually very progressive and looked into a transition very similar to what CP just described for their intercity passenger rail operations. Where can we go from our current diesel fleet to get a full zero emission in the future? And it was identified that with our help that hydrogen fuel cell technology could work very well for their services compared to other competing options. The H2 Goes Rail project was already mentioned by my colleague at Ballard because the product uses Ballard fuel cells. And that's a collaboration between Siemens and DB, funded by the German government and others. And obviously the sub-suppliers are heavily involved with this project as well. I have a little bit more detail on the next slide. On the top right is also a big milestone here for North America. This is the San Bernardino County Transportation Authority project. The vehicle will be supplied by Stadler, and we are supporting this project and have been supporting the project since the start. And the important part about it is that commercial in-service passenger operation is scheduled to start in 2024. Again, trial runs and so will happen earlier than that. The first vehicle is being constructed in Switzerland. The testing will be in Europe, followed by North American testing. After that, then there will be in-service operation. We are also working here very closely with the regulator, the FRA, to actually get this train approved for mixed service here in North America. One of our Canadian projects is with the Southern Railway of British Columbia, largely led the consortium. The consortium is largely led by UBC, so the University of British Columbia, and the team there. Very similar to the CP project from the perspective that it's a retrofit, take an existing platform, change the propulsion system, rebuild it, over to actually demonstrate that this can work and that this is a commercially feasible way of doing that, while also learning how to incorporate that, leveraging existing locomotives. If you have to start from scratch, that's always a possibility, as many of the other projects have shown, but often there is a cost advantage, very similar to what CP just mentioned, if you actually use existing platforms and can rebuild them, especially as the remaining life for many of the locomotives that we have here in North America is very long. Okay, here a little bit more about some of the US and North American projects. On the left-hand side is Caltrans, so that's the California Department of Transportation. Caltrans owns the intercity fleet, rail fleet here in California. It's operated by others. It's a relatively complicated regulatory structure, but Caltrans is the actual vehicle owner and has control over the vehicles. You see the corridors where these trains operate. Some of you might have been on some of them. They're marketed differently in the south. So the region around Los Angeles is marketed as the Pacific Surfliner. Between Sacramento and San Jose, Oakland, so roughly the San Francisco Bay Area, is the Capital Corridor trains. And then we have the San Joaquins traveling in the Central Valley. These are typically consist of locomotive-hauled double-decked coaches. And Caltrans wanted to reduce their emissions, and we assisted them with technology assessments and feasibility studies to see what technologies could actually work for these intercity services. And subsequently, also the government in California, the Governor Newsom, has signed an executive order mandating that the off-road vehicle fleet be zero emission by 2035, and off-road vehicles do include rail vehicles. So Caltrans's plan is to transition the entire fleet of locomotives on the intercity fleet to zero emission by 2035, and we are supporting them with that endeavor. That's interesting from a power perspective, as none of these locomotives currently exist globally, so they have to be developed similar to the CP project. They are also very high horsepower locomotives, also very similar to the CP project from that perspective. Typically, they run 4,400 horsepower locomotives. Is it going to be all new build and new purchases and retrofits? That's not entirely clear yet. It's likely going to be a mix of both. The locomotive that you can see here is one of Caltrans's new Charger locomotives, and the last two of these have just been delivered this year. So there is a lot of remaining life in them. Moving on to the SBCTA project, the first commercial hydrogen vehicle in the US that SBCTA ordered. We compared lots of different technologies for that, planned in service operation in 2024. Very similar to the Alstom product or the Siemens product. They are all regional type passenger trains, just from a different manufacturer, and here in this case focused on North America. All right, I need to hurry up a little bit. The Green Road project here in with the Southern Railway of British Columbia. I already mentioned the conversion and the H2 Goes Rail project in Germany in collaboration with Siemens. Renewable hydrogen productions through electrolysis is the planned in service operation 2024 and our collaboration. Here, I'm not going to talk to that a lot. This is my last slide. Just watching time here. Where are the different technologies, zero emission technologies, actually suitable for the different services? and we split them into all of the different, or the main passenger services, as well as the different freight services. What we can already have commercially available across all of them is the current wayside electrification. So either overhead, which is what we typically see, or third rail. It works really well. It's zero emission at the point of use. The biggest problem is it's actually extremely capital intensive, and with that we need alternatives. Batteries will work in several different applications, particularly if you combine it with partial electrification. We have some of these trains operating on our network in Germany, for example, but a lot of the network is already electrified, so that makes sense. But for some other applications, it's actually not that useful. The half circle indicates where you might do a hybrid. So you have batteries and another power source. And most of these hydrogen trains, for example, are hybrids. They have hydrogen fuel cells plus batteries on them, or some other sort of energy storage. And then at the bottom, hydrogen or hydrogen vehicles, you can see they're suitable for almost all rail services, with a few exceptions currently. Thank you very much. And here are my contact details, and I'll hand back over.
Thank you very much, Andreas. And apologies, we had to rush there, but we also have one more panelist lined up. With that, I'd like to welcome on stage Ian Hodkinson from Alstom. Ian, please welcome on stage.
Great, thank you. I hope you enjoyed seeing the island in action. Before we continue talking a little bit about the island, I just wanted to share a little bit about Alstom and our vision for green technology as we go into the future. With the acquisition of Bombardier Transportation by Alstom Transportation, we're experiencing a whole new Alstom. Alstom has become the second largest passenger rail provider in the world, with the widest portfolio of products, the greatest geographic coverage of any supplier. Alstom's story is also a Canadian story. Our North American headquarters is going to be based in St. Bruno, Quebec. We have sites in La Pocatière, Montreal, Kingston, Thunder Bay, Toronto, Edmonton, and Vancouver. Alstom offers a full portfolio of zero-emission solutions, including electric trains, hydrogen trains, and battery trains. And the island is a great example of our message, mobility by nature. Let's talk a little bit more about the island itself. As Andreas mentioned, the island is a regional train, which is a type of train that usually serves smaller cities, usually in a European context. It's a two-car train set. Each car is about 54 meters long, so about 108 meters for the overall train. The car is about 2.75 meters wide and is capable of bidirectional operation. Each side has 4 doors and it has a range of approximately around 1,000 kilometers. The maximum speed is around 140 kilometers per hour, and it can accommodate between 150 and 160 passengers depending on the configuration of the interior. The fuel cells and hydrogen storage are mounted on the roof, and batteries and traction power equipment are mounted underneath the car. As some of the panelists mentioned earlier, power is provided by a combination of both hydrogen fuel cells and by batteries. When accelerating, both the fuel cells and the batteries provide power to the traction power system. When coasting, the fuel cells recharge the batteries and provide power to the wheels. And when braking, energy is regenerated and stored in the batteries. Fueling for some of the demonstrators we've done recently is done by a dedicated fueling station. Basically, hydrogen is trucked to the location on site, is compressed via the fueling station to a pressure that's suitable for refueling the vehicle, and is transferred on board the vehicle. What's encouraging is the performance has been shown to be equivalent to similar diesel vehicles. So the island is able to actually act as a sort of plug and play for comparable diesel regional trains, replacing diesel service with hydrogen-based service. And the wonderful thing is the only emissions are H2O, water. If we look a little bit at the history of the island was developed between 2014 and 2016. It was successfully homologated in Germany in 2018 and entered passenger service in Germany in 2018. It's had over 200,000 kilometers of passenger service and is currently in demonstration around Europe. So in Poland, Austria, France, Netherlands, Sweden, and more demonstrators are contemplated. And we're hoping perhaps that we'll be able to have a demonstrator at some point in the future in Canada as well. Beyond hydrogen, Alstom offers a full portfolio of other green mobility and zero-emission products. Here are a few examples. There's the Caradia Continental Battery Multiple Unit, the Talent 3 Battery Multiple Unit, the Caradia Stream Fuel Cell Multiple Unit. An interesting example is the Caradia Polyvalent, which includes both fuel cell and conventional electrification with capability of running with overhead wires. We actually believe that all three technologies can be complementary: conventional electric trains, batteries, and fuel cells. Each has a different application, and we certainly look forward to engaging with the community to try and determine which technology is best suited for each application. Fuel cell trains exist and work today. Alstom has a complete portfolio of green solutions, and we're looking forward to engage with the community to discuss application of these technologies and determine the best technology for each application. Alstom is looking forward to being your green mobility partner.
Thank you so much, Ian. First of all, starting off with a brilliant video and learning more about the Caradia Island, definitely exciting. And with that, I'd like to welcome all our panelists back on stage to discuss some of the questions posed by the audience, and also just to discuss their presentations in further detail in general. And so, yeah, there's a lot of different pieces to put together here. You've got, you've got technology, you've got expertise coming in from the OEMs on the panel here. And at the same time, we've also got lessons learned from, project planners and implementers, and from the owner-operator side. And then there's also another very important piece to discuss, which is fuel supply configurations and basically ensuring fuel supply for a new alternative fuel going forward. So maybe we can kickstart with a bit of a discussion about the technology itself. And first of all, let's just establish this, and especially we'll draw on the expertise of our OEMs here. As far as the technology readiness levels are concerned, like if you were to label the TRL of your products, and in general the hydrail applications we're looking at here, what's your perception, and where do you think you stand? I'll start off with a few words from Terry. Terry, with Ballard's products on hydrogen fuel cell locomotives, and maybe even on light rail, at some point. Do you see that these technologies are far ahead when it comes to the TRL scale, the technology readiness level scale?
I think the technology is ready. As I look at the different applications, from the light rail to the heavy rail, I see the difference between where the technology is relative to some of the other applications like bus, for example, really is more to do with the codes and standards. So for freight, for example, for the heavy rail, the codes and standards, it's almost a blank sheet of paper right now. There's a lot of learning that has to happen from the suppliers, from the industry, and from the Standards Association. So that's probably farthest away. Whereas all those metrics are clear in some of our commercial markets, like bus, for example. In light rail, we're still on the learning curve, but we're much farther along. So that's how I see the difference between these applications.
That's very interesting. Thanks, Terry. And yeah, before we delve a bit into codes and standards and some of the gaps along those lines, which of course we will discover going forward, a quick check with Ian. Ian, any alternative thoughts or any additional thoughts on, where technology stands today?
Well, I mean, I think there's different perspectives to it, Samia. I mean, first of all, I mean, it's from a feasibility perspective, I mean, there are products that exist, so we're quite advanced in the TRL level. So in terms of establishing that the technology can actually function and operate, I think that's achieved, and certainly with some of the work that Kyle's working on in CP, we're quite close, and Andreas mentioned a number of projects as well. So, and from a feasibility, as you said, Alstom has 200,000 kilometers under our belt. I think some of the good points that you brought up, Terry, is a question of the overall infrastructure. So there's the standards framework that needs to come along. There's a question of the hydrogen supply chain, the infrastructure, fueling. That all needs to come along as well to provide sort of the full picture that'll enable success and to advance up the TRLs as we go forward to the next couple of years.
Sure. And one more thing to check in there, and it's one of our audience questions as well. When it comes to safety, if you can shed some quick light on, primary concerns when it comes to operating an H2 locomotive, or even a hydrogen trail in the light duty segment. Any safety concerns that especially stand out? And maybe I'll turn to Kyle here, and I can come back to Ian and Terry just to quickly check there as well.
Yeah, I mean, I would say I agree with what Ian and Terry are saying. I think for us, it's really standards, and it is clearly a blank sheet of paper. So we have certain things and checks and balances that we do it as an industry through the Railway Safety Act, HAZOPs, risk assessments. And of course, we have a competent staff of qualified technical folks, including professional engineers. And then, we're currently working with Transport Canada as an example, keeping them advised on our project. And there are certain provisions within the regulations that allow us to modernize platforms with new technology. So I think, our objective, get the locomotive moving. We can get it into yard service without very much of a regulatory leap there. But to get it onto the main line, we will. So it's very important that we keep the regulator engaged. And we've also applied for funding with the Canadian Standards Association as well to make sure that we can formalize a document. And then the last thing I'll say is that these conversations are starting to happen through the Association of American Railways as well in terms of standards. So definitely think the technology itself is ready in terms of it functions, and we can clearly move locomotives on their own power through these technologies. I think as an operator, we're going to have to figure out how to operate it efficiently through precision scheduled railroading. And I think that's what we do best. And, it's pretty exciting. But I think that's where you're going to see the technology reach a whole new level, because in the words of my boss, what we do really well in the freight industry is we break things really well. We slam into lots of heavy equipment. So I think that's really gonna ensure that the technology becomes quite robust in the long run.
Yeah, sure. Thank you, Kyle. And so, yeah, while we're discussing some of these gaps, and especially the bit that you mentioned about engaging the regulator, we've got Andreas. Andreas brings experience from a variety of jurisdictions here, as we saw in your presentation, Andreas. Any specific thoughts or any specific observations when it comes to your experience in different jurisdictions? Like, have you seen a one way being better than another when it comes to engaging the regulator, or when it comes to a legislative push in a particular jurisdiction that drives forward progress, that drives forward progress much more efficiently compared to another jurisdiction. Any thoughts along those lines, Andreas?
So generally, what is very useful is to engage the regulator early. They want to know what's going on, and actually many of them, they often have the perception that, hey, we want to stop anything that you're doing. That's actually not true. They're generally relatively open if you involve them appropriately and if you involve them from the beginning. And yeah, I see some of my colleagues also agreeing, yeah, absolutely. What they really don't like is if you present them with an end product or something that, hey, look, we've done this, can you please just say yes? And all of us wouldn't necessarily feel that great about it, but if you involve them early on in the project, it's usually a lot smoother, and they all know that the industry has to change. They also know that very often there's high policy perspectives that we have to change to alternative technologies, and they support that. The FRA, so the regulator here in the US, for example, has a specific division looking into alternative propulsion systems and helping people come along, and they have a variety of different programs in how you can do that. So it's different if you operate a locomotive in a yard, for example, versus over the road, versus in passenger service, for how long you want to operate that, and they can guide you with that, and they will. So generally, my experience with the regulator has actually been positive. Also related to that with some of the standards, as Kyle mentioned, the AAR is looking into some of the standards also for some of the components and refueling time and refueling connections. There's some international standards in progress and being worked on right now as well. So that not everybody is doing their own thing, which is definitely a possibility, but then it's complicated to have interoperability, which is one of the biggest things for railroads. So that's also ongoing. You also mentioned the safety question, and that often comes down to the regulator too. So the primary purpose of the FRA is to ensure a safe operating railroad. And this is exactly where they're digging into. On a relatively high level, can hydrogen be operated safely in a railway environment? The answer is absolutely yes. Is it any more dangerous than some of the other alternatives that we're using, including diesel? Also probably no. It's just very, very different. If you're going from liquid fuels over to a gaseous fuel, that's one of the biggest changes. Also, if you have very high voltage overhead wires or wayside electrification, there's a lot of safety risk associated with that. Don't touch it, in short, and we just need to make sure that people don't. So it's just a different mindset. But with that is a big public perception challenge as well. The public, it depends where you are. In some regions, people just love all of this new technology, no matter what it is. In other regions, people are a lot more skeptical, and it's always a big thing and a different thing if it operates in your backyard. So there's also big public outreach.
Along those lines, another audience question that has come about is, so basically, what do you see as main challenges when it comes to certification of rail systems? Then, and so I'll maybe start off with you again, Andreas, and then we will move on to Ian and Terry and Kyle. Yeah.
Okay. Yeah. I will actually, because I talked already a lot, I want to give others more of a chance, and product developers can talk more about that. But certification, it depends what you mean with that. So there is, for example, the concurrence process of the FRA. Do you mean that with a certification? Do you mean any individual components? Are they CE certified or ISO certified or something like that? So I'm not entirely sure where the question is going, but the reality is, yes, both of them are possible.
Yeah. I'll maybe let Ian shed some more light on that. Ian, any thoughts on certification matters?
Well, I mean, I think it depends a little bit on jurisdiction. Obviously, in Canada, we defer to Transport Canada. As Kyle and Andreas mentioned, I think the secret to successful certification is early engagement with stakeholders and with in our case, Transport Canada, and certainly referring to other projects and other cases of certification. In our case, we're homologated in Germany, so that gives us a wealth of documentation that we can use to apply towards risk analyses and safety cases, and some things that Kyle mentioned as being applicable in our context. So I think, again, it comes to early engagement, and it certainly helps if there's a backlog of information available from other sources.
And Terry, with the diversity of experience that Ballard brings with cases in Foshan and then now working in Canada with CP Rail, any lessons learned from your experiences?
Yeah, I think most of my colleagues have captured it. I do think, and things will get easier as more and more products get certified, and the certification agencies get used to the technology. I think these challenges will diminish, but needless, I think the key is early integration of the certification organizations onto the team, keep them abreast on what's going on.
No, that's great to hear, Terry. And so, well, the conversation maybe is driving a bit towards collaboration in general, strategic partnerships, and public-private partnerships as well. Maybe we can try to explore that a bit, because I'm sure besides lessons learned about technology, some of the audience is interested in learning lessons learned about the project management and project planning side of things. And so we've basically got two couplets of OEM and owner operator here. And maybe I'll start with Kyle. Kyle, any specific lessons when it comes to just strategic partnerships, project planning, collaboration, and these aspects of taking a project forward?
Ooh, that's a big question. There's a lot of answers to that.
Yeah, for sure.
So I'll tell you, I worked for an OEM, and then I've worked for an operator, and I would say that the way that you approach the problem is very different. I would say as an operator, what we excel at is essentially either being reactive to events as they occur, but being proactive to prevent events, and we move very quickly because our revenue generation is we got to get something from point A to B to get paid. Basically, that's how it works. So now we take that operating experience and we're now thrown a bit of a curveball. Here's a new problem that's affecting the climate. So normally we're just used to looking at our own operation and we've got tunnel vision. And so we're taking that operating experience and trying to now develop something and essentially compete with the OEMs, which is a little bit bizarre if you can think about it that way. But ultimately our goal is to not buy a net new locomotive. Our goal is to get into our modernization program and reutilize our existing platforms before 2030. So if you think about that, it's only 8 years from now. So I think approaching the problem, you have to make sure you balance out the technical requirements and considerations, the testing and validation, but with that aggressive operating culture that you have. And so we initially, I would say our goal is to, get to that prototype, get the prototype moving. That it's not going to be perfect because it's a prototype, and then you make it better. So we had to get to that first platform and then build up from there. And then in parallel, again, we talked about regulator and making sure that we're not moving too fast, and we're doing our due diligence to ensure safety, which is also one of our core foundations. So again, I would say in this type of environment that we're in, and at the speed that climate change is occurring, it's very important to kind of get that first proof of concept out there and then build it up. And the last thing I would say is that we deliberately did it internally, because if you partner with too many stakeholders, you end up with this big consortium, but you can't get the product out the door. So we wanted to, and then fundamentally, because you're leading the initiative, you need to know every nut and bolt from the ground up, because you're ultimately going to have to support it after it comes to life. So I would say our approach at CP was very painful and deliberate to gather that domain expertise as well in parallel. And so we were very strategic about the partners that we chose.
Very insightful, Kyle. And yeah, we're actually running out of time here, so I will have to rush us through the last couple minutes here. Maybe I'll do a quick roundtable. Some final words, 30 seconds. Your final thoughts on the future of Hydrail, based on what you've seen so far. I'll start off with Terry here. Terry.
Thanks, Samia. Yeah, so final words. I would just say that definitely, when we look at the limitations of batteries in trying, and catenary in trying to take rail to zero emissions, hydrogen fuel cells is going to play a big part in the long range, heavy duty applications in those sectors. So there'll be space for everyone and every technology, but hydrogen fuel cells is definitely well suited for those applications that require the long range and heavy loads that we see in light rail and heavy rail applications.
Thank you, Terry. And to complement one OEM from one of our other OEM panelists, Ian, any final thoughts, last words?
Sure. I mean, I think there's a couple of things. One is that Terry, you mentioned it. There's different solutions for zero emissions. Every application is going to have a unique solution. Definitely a space for hydrogen. Definitely, particularly in the Canadian context, with the distances and the nature of our rail network. So definitely a space for hydrogen going forward. I think the real thing to contemplate is we're very focused on the rolling stock in our conversation today, but I think a real thing that's important to develop as well is the concept of infrastructure, hydrogen supply chain, types of hydrogen, refueling, and making sure that all that's in place, because that's going to be key to the success and driving this forward. So I think that's one aspect that really needs to be looked at, and we need to continue dialogues like this one in order to keep the awareness going and make sure that we have success going forward in the future.
Yeah, thank you for bringing that to light, Ian, because, given the time, we definitely focused a bit much on the rolling stock. The fuel supply chain is yet another very critical piece. Unfortunately, we won't have much time to talk about. We're in the last minute here. But I also encourage, our audience members here to visit the next session at 12 p.m. EST, which will be discussing the strategic, economic, and environmental drivers behind Hydrail, and maybe you'll get to hear out a bit more on the fuel supply chain there. I'll quickly check in with Kyle. Kyle, any last words? You've definitely got us excited with CP Rail's pilot projects there. So
yeah, just foot on the gas, Canada. We gotta keep our foot on the gas here.
Right on. Thank you, Kyle. And Andreas?
I echo what everybody else has said. I think there's a bright future for Hydrail. I also like that it's being accelerated, and I see great potential in North America and other markets where there is very limited electrification. It's going to happen. We can't all help.
Yeah, and our apologies to our audience members if we couldn't answer any specific questions you had, but I would definitely welcome you to the networking sessions, wherein you may have a chance to meet our panelists at one-to-ones or just explore these topics further as well. That said, we will be entering a 30-minute lunch break pretty soon here, and we welcome the audience members to visit the exhibitor booths for more information as well. Thank you so much to our panelists here again, and thank you so much to our sponsor, Ballard Power Systems. Look forward to staying connected with you all, and hopefully we'll be talking more about these projects, going forward at subsequent conferences and at other forums. Wishing you all the best to your teams as well, and look forward to more updates. Thank you all.